So I just wanted to give a little introduction to alignment and why myself and other like-minded professionals pay so much attention to something that might be seen as a minor detail. It is a minor detail, but it's a very important one because it plays such a big role in how we do everything. So the movements that we might see in the gym, in a class, or on the sports field are all determined by how we line up, so how we are aligned relative to the other parts of our own bodies. So I want to demonstrate that with this hip model right here and have a little look at the ball and the socket joint of the hip. So this big important one right here. So there's a lot of range of motion available at that joint. All right, it can move in all three planes reasonably freely, but the thing that is always going to limit how this bone can move relative to this one is the shape and structure of that socket relative to that ball that sits within it. There's not a huge amount we can do about that. There's not a huge amount we can do about the anatomy, but there's a lot we can do about where that socket is in space, so where these two bones are relative to each other. So we have a look at this thigh bone moving, so that ball moving within the socket, and we go through hip flexion. Right, so hip flexion is this action, which might be a squat. If this is happening, it might be somebody running over, it might be a hurdler, it might be a sprinter, it could be anything really that requires that action right here, which is most sports really. At some point, this ball will hit the top of the socket, which on this model is round about here. So that's about as far as I can go. If I try and go any further, I will break it. So I will crush this bone against that one. So in a human being, in a live human being, there are little structures in between there, and if I was to force that any further, I would damage and break those structures, which is not really what we want to be doing. So if I am in, or this pelvis is in, say, this position, okay, so it's tilted slightly forwards, and I go through hip flexion, I'm getting to about there, and that's it. I can't go any further. So if I want to move this thigh bone any higher up relative to the room, so if I've squatted, for example, I've got to parallel around about here, then I've gone past parallel, and that's about it. That's all I can do. Right, there's an angle between that pelvis and that thigh bone. That angle is going to remain pretty much constant. The range of motion between the two bones is going to stay pretty much constant because of the anatomical limitations, because of the limitations of that socket and the ball that sits within it. Now, if I want to move this person deeper into the squat or higher into the knee drive, I can either force it and I can hurt them and I can damage it and I can break my model, or I can shift the position of the hips and in doing so free up some extra range of motion. So I can squat a little deeper or drive the knee a little bit higher because I've moved the hips and freed up some space within that joint. So alignment and where the hips are positioned is the most important thing when it comes to how the thigh bone, so how this femur can move relative to the environment that it's in, so relative to the floor or relative to the walls or relative to that hurdle on the athletics track or any other measure of motion that we're wanting to look at. The important measure is how this bone moves relative to this one. Right? So we can't really change that, but we can change the position of the bones. So if a set of hips is neutral, or as close to neutral as we can get it, that gives this thigh bone, that ball, the best opportunity to move with the most range of motion through all available planes. As soon as this pelvis is in a different position, so as soon as it changes, the available range of motion of this bone relative to this one is still the same, but this one has moved. So therefore, the range of motion of this relative to the ground or to the hurdle or to the football goal has now changed. So to give that squatting example again, if I tilt this pelvis forwards and this this former person goes through a squat, it gets to about here and it runs out of space. If I want to go any further, I have to do that, which then frees up a little bit more range of motion. And that's what we see as buttwing in the gym or in a class environment. When you see somebody squatting and they tuck their bum or they tuck their pelvis underneath them, what they're actually doing is freeing up more range of motion in the front of this joint right here. So what they're actually doing is quite a smart solution as far as their hips are concerned. They might be setting up some other problems in some other areas, but in the short term, they're solving the immediate problem of running out of space in the hip joint by rotating their pelvis posteriorly, so tucking it underneath them to free up some more space. So really, before we start looking at stretching people and trying to change their structures and doing anything complicated, we should be looking at the really first point of assessing and correcting range of motion and movement mechanics, which is alignment. Where is this bone? Where is this important one? Where is that? And if that's in as better place as we can get it, there is the appropriate range of motion available in this one. So if before we start looking to try and change the range of motion of this bone relative to the floor or to something else in the environment, the walls, hurdle, goal, anything, let's look at where it is relative to this, get this one right, and this one will take care of itself.